Hello everyone again. Thank you for joining my presentation. I'm Winnie Shen from University of New South Wales. So today I'm going to present my work on from surface to semantics, semantic structure parsing for table-centric document analysis. So in this presentation, I'm going to firstly talk about our background, the contribution, the methodology, and the experiment and our results. So this is an overview of our work. The aim of our research is to contribute towards reliable and automated document analysis. So specifically, we focus on document table understanding. Because for a lot of industry PDFs, like this financial report showing up here, the documents and the tables embedded in the documents are actually very important. So we want to build a reliable and automated document analysis tool to uncover the table values. Why we're doing this research is because, again, documents are vital carriers of information across domains such as government, enterprise, and science. Among the PDF, tables serves as the most important carrier of data, illustrating quantified knowledge and serving as the core of the documents. There are a lot of research on document analysis, and usually document analysis involves the following steps. So firstly, we have the documents, and then we will perform the OCR techniques to convert the raw text into machine-readable text. And then the NLP techniques can be used to perform the embedding and turn raw text into structured, semantically labeled data. Then the machine learning and deep learning models can be used to do task-level reasoning and decision-making, where the results can be used to do downstream tasks, for example, the document understanding, document classification, and document question answering, and so on. Well, there have been many works on document analysis trying to analyze and extract the table data from PDF documents with salient tasks including document label analysis, table data extraction, table structure analysis. However, existing studies only focus on the shallow level and the visual level of data extraction, overlooking the deep semantic relationship between the table and text. But actually, table and text, they are actually together, they have associations. They jointly supporting the reasoning. Because sometimes when we want to know which text paragraph introduced the specific table in PDF, when we also want to ask how to retrieve the table related to a specific question or a query. So that's why we want to build a table-centric document analysis to uncover the value of table text associations. So now we are going to state the contribution of our work. So here are our contributions. Firstly, we designed a Do tabular, which integrates a complete document pre-processing pipeline and semantic relationship analysis of PDF elements, enabling both semantic structure parsing and domain-specific table retrieval. We proposed the first PDF semantic level dataset modeled around the table-centric structure and trained the table text association model to effectively analyze the relationship between tables and their contextual contents. We conducted a comprehensive evaluation of Do tabular on nearly 4,000 pages of real-world PDF documents, demonstrating its superior performance and practical utility in semantic structure parsing. We believe our proposed pipeline could be very useful in real-world application because, as we mentioned before, tables are usually condensed information carriers, and users frequently need to extract certain table in documents to extract specific information, especially for very lengthy documents like this financial report. The table and text association could be a very valuable factor when locating and extracting the information in PDF. Well, here are some use cases demonstrating why this tool can be very important or useful in real life. So for example, in the financial sector, analysts often need to retrieve revenue definitions along with relevant tables from reports. In the legal domain, contract reviewers must connect the clauses with compensation tables. And for public sector, policy analysts frequently extract demographic summaries and related statistics from lengthy government reports. So those are all the use cases for the table text association model. Okay, so now let's have a look at the proposed do tabular pipeline. Well, this is an overview of the proposed do tabular pipeline. Well, this pipeline includes the document structure, preprocessing module, relation-aware table annotation module, the model training part, and the application part, including table-centric semantic parsing and domain-specific table retrieval. So this one, the first one, the document structure preprocessing module, mainly perform the layout detection. Well, the input could be one or a set of PDFs, and then each document will be firstly split into separate pages, and then we will perform the document layout parsing to recognize different layout blocks. So that includes, for example, the title, the list, the figure, the table, and the text. And then the OCR techniques are used to extract the text content in each block. Because there's no available public dataset to be used for table text association analysis, we constructed our own dataset. So here for the relation-aware table annotation pipeline, we invited two experienced experts, manually annotated the related table and text pairs. And then after the annotation, we also performed the annotation reconciliation to make sure the analyses are correct, and we constructed a successful dataset. Then the annotated dataset will be used for table text association model training, and the detailed training and testing result will be specifically discussed in next section. And lastly, we have the application module. We have the table-centric semantic parsing, which is to retrieve all the relevant text for a given table. And then for the domain-specific table retrieval module, is to provide the most relevant table for a user query. Okay, now let's have a look at the experiment settings and the experiment results. Again, since there's no available public dataset currently exists for the document level semantic analysis, we constructed our own dataset. So specifically, the datasets are downloaded and are developed from the archive and PubMed Central following the data annotation pipeline that we mentioned before. And this table here summarizes the dataset statistics. We annotated 227 PDFs, where around 16,000 positive and negative table text pairs were constructed. To evaluate the performance of our proposed do tabular pipeline and compare it against the baseline modules, we define the following 4 research questions. Firstly, can do tabular's TTM module effectively determine whether a text block describes a specific table block? Secondly, can do tabular accurately perform semantic parsing of PDF documents using tables as structured queues? Third, can do tabular reliably retrieve relevant tables and their contextual text based on user-provided natural language queries? And lastly, does do tabular outperform the baseline in time efficiency and maintain a low latency? So this is the result for research question 1. Currently, our TTM supports multiple pre-trained modules as encoders, including the BERT, BART, and the Robota. We compare TTM's performance with 3 state-of-art large language models, including the GPT-4o, Gemini 2o, and Cloud 3.5. So from the result, we can actually see that TTM outperforms the 3 LLMs, and among which Roberta is the best performance, achieves around 90% precision recall and F1 score, demonstrating strong capability in accurately identifying the table and the text blocks. So here, for research question 2, we conducted a document-level analysis of TTM's performance from a table-centric perspective. So in our test set, each document actually contains multiple table and text blocks, which may be either related or unrelated. We evaluate the performance using 3 criteria. Firstly, the number of documents that all the table text relationships are correctly identified. Secondly, the number of documents that relate to the table text pairs are correctly identified. And lastly, the number of documents that all unrelated table text pairs are correctly identified. Well, from the result, it actually shows our do tabular pipeline achieves the highest performance across all correct and post-correct, outperforming all the decoder-based LLMs. Well, this again demonstrates the superior ability of our TTM module. So here, this one is the result of the domain-specific retrieval, which corresponds to our research question 3. So given a natural language query, Table employs the TTM-based ranking strategy to compute the semantic relevance between the query and the given tables within the PDF documents. And then it will return the top K ranked tables as retrieval result. So for example, when K equals to 1, we're actually retrieving only the most relevant table. And again, from the result, we can see that our do-tabular has a strong ability in relevant table retrieval as well. So this one shows the time overhead of our do-tabular and 3 LLMs. So the result, we can see that the do-tabular achieves both average and median time cost below 0.01, which outperforms the other 3 LLMs. And then these two figures shows the time overhead of batch-wise analysis. We can see that do-tabular consistently outperform all the LLMs across both matrix, maintaining a significant time advantages. And this is particularly critical in real-world scenarios involving large volumes of PDF analysis. So that's my presentation. Thank you for your time, and any questions?
Any question from the audience?
I might have missed the architecture of TTAM. Is it like a encoder essentially, since you used it for throughout purposes?
Yes, so this is the structure. Our entire pipeline is called do-tabular, and the TTM is the text table association aware annotation module. So this is actually we're using the robotics to recognize whether a table has certain association with the corresponding text.
Okay, so yeah, thank you. That answers my question.
So
There's another question, I guess.
I'll try to be quick. The first question is it's about the dataset. So first question, is it available somewhere?
The data set, this one.
Yeah, is it available? Do you publish it?
Yes, I publish it.
Okay. And second question very quickly is you said you had several experts to build this dataset. How did you distribute the experts, for example? Is there one expert that did the archive analysis and another one the PubMed? Is it distributed? Did they do cross-checking of the papers?
So basically, this do half-half. So we invited 2 experts. Half of the archive PDFs are distributed among 2 experts. Yeah, and then they do cross reconciliation.
Any other question?
Thank you for the great talk. I wanted to know how you come up with the features for each table. So you need the columns, right?
Each feature is about the tables. A good question. Actually, here, because we're doing the semantic analysis of the table and text, so basically we perform the OCR techniques. Firstly, extract the table and text contents of text, and then we perform the text embedding. So actually, what we did is comparing the association between 2 text paragraphs. Yeah.
Thank you so much.
So let's turn to the speaker again. And let's move on to the first spotlight. I don't know if the first question. Yeah. Okay, I think.